Hello, my name is Blake Summers, and today we are taking a look at question 2 of written homework 1 in Math 2060, Fall 2017 with Jim Brown. After reading through the problem, we can arrive at a couple of objectives. 1. Draw a graph of the curve y equals x cubed over 2 plus 1/2. 2. Find and put on the graph two unit tangent vectors at the point 1, 1 and two unit normal vectors at the point 1, 1. Let's start by plugging in some values for x and seeing what the general shape of our graph is. Now that we have a general idea of what our graph looks like, we can begin to tackle the first unit tangent vector. Now, to find a tangent vector, we can start off with finding a tangent line at the point 1, 1. In order to do that, we're going to need to take the derivative of this function, the first derivative, and plug in our x and y values at x and y in order to get the slope of that line. Now that we've taken the derivative of this function and plugged in 1 for x, we can get the slope of the tangent line at the point 1, 1 is 3/2. Now, we can create a corresponding vector in the same direction by analyzing the rise over run of the slope of a line. Now, 3 is going to be our y component of our vector and 2 is going to be our x component of our vector. Now we have a tangent vector at the point 1, 1, so the next step is to make it a unit tangent vector, which is when you divide by the magnitude of the vector. Now that we've divided by the magnitude of this tangent vector, which we will call u from now on, we have arrived at our first unit tangent vector being 2 over square root of 13, 3 over square root of 13. Now, analyzing the graph, you know that the only other unit tangent vector at this point 1, 1 is going to be one going in the exact opposite direction, which will be negative 2 over square root of 13, negative 3 over square root of 13. Our next step is to plot the two unit tangent vectors at the point 1, 1 on the graph. We can do this and get a general estimation of how to do this by getting some decimal approximations and making it easier to picture them in our minds. The next question the problem poses is finding two unit normal vectors at 1, 1. Normal vectors are actually vectors that are perpendicular to the graph at this point, and so we can do this by actually taking the opposite reciprocal of this tangent line slope and then use the same process that we went through here to arrive at two different unit normal vectors. Just to walk you through this process one more time, we're taking the opposite reciprocal of this slope of this tangent line in order to get a line that is perpendicular to it. Now, using the same method of analyzing rise over run out of this slope, we arrive at the vector negative 3, 2. Divided by the magnitude will give us the unit vector in the same direction, and that ends up being negative 3 over square root of 13, 2 over square root of 13. And as we did before, we take the opposite, and that will give us the second unit normal vector at the point 1, 1. Now, in order to graph these and make it easier to visualize while graphing, we have some decimal approximations, and at this point, you have found your two unit tangent vectors and your two unit normal vectors. Now, it is important to note that vectors are not bound to a certain point, so these two unit normal vector and two unit tangent vectors at the point 1, 1 are not actually there. We're just putting them on the graph there in order to better represent the fact that they are tangent and normal to this curve at the point 1, 1.